Now let's pray. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come. Thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. For thine is the kingdom, and the power, and the glory, forever and ever. Amen.
Hello there, grade 6 pupils. This is Teacher Van Van, and I'm going to discuss describing the exponent and the base in a number expressed in exponential notation. But before we start, let me read the learning objectives first. During and at the end of the lesson, the pupils must be able to distinguish the exponent and the base in the number expressed in exponential notation, simplify and locate the exponent and the base in the number expressed, and cite the importance of identifying the exponent and the base orally. Let me ask you something. Have you heard the words exponential notation? How about exponent or a base? Okay, you might heard about it, but have you noticed what they really mean? Oh well, in this video, we are going to discuss and tackle about what are exponents, base, and exponential notation in general. Alright. Exponent is a number that states how many times the base number is to be used in multiplication. It should be placed on the right side at the top. Example, b and n, where n is an exponent here. Another example, we have 2 and 2, where the 2 above is an exponent 2. Next, we have base. Base are any numbers or letters that is below the exponent in the left. It is way bigger in size compared to an exponent. Example, b and n, where b here is the base. Another, 3 and 2, where 3 here is also the base. Let's move forward to what is exponential notation. A common language is needed in order to communicate mathematical ideas clearly and efficiently. Exponential notation is one example. It was developed to write repeated multiplication more efficiently. For example, we are going to multiply 2 5 times by itself. Instead of saying 2 times 2 times 2 times 2 times 2, we have 2 and 5, or be read as 2 raised to the power of 5, or 2 to the 5th power. Another example, we have x to the power of 3, or x cubed. If we are going to expound this, we say x times x times x. Now let's try to solve this exponential notation. We have here 5 raised to the power of 3, or 5 cubed, where we say 5 times 5 times 5 is equals to 125. Why? Because 5 times 5 is equals to 25, and 25 times 5 is equals to 125. Let's try another example. 2 raised to the power of 3, or 2 cubed. We say 2 times 2 times 2 is equals to 8, because 2 times 2 is equals to 4, and 4 times 2 is equals to 8. Are you ready to take more examples to the next level? If you're ready, then listen to me carefully. If we have 7 times 7 times 7 times 9 times 9 times 9 times 9 times 9, we have 7 cubed or 7 raised to the power of 3 times 9 raised to the power of 5. In here, count the numbers of 7s. Alright? Copy the operation used, which is the multiplication or times, and count the numbers of 9s there. We have 7 raised to the power of 3. Since 7 is 3 times multiplied to or times 9 raised to the power of 5, since 9 is 5 times. Now, let's go forward to our last example. We have 2x multiplied to 3x. 2 times 3 and x times x. Our answer is 6x squared. How is that possible? Hence, we all knew that 2 times 3 is equals to 6, right? Now, we come up with 2 as an exponent to the x, since we add the 2 invisible 1 in the 2 x's. So 1 plus 1 is equals to 2. Since x is our base or letter, it read as x raised to the power of 2 or x squared. Since we are done with our examples, here are the things we need to remember when solving exponential notation. In this example, 10 cubed or 10 raised to the power of 3, where we say 10 times 10 times 10 is equals to 1000. Where the numbers of zeros there is automatically beside the 1. It is only applicable to number 1 and followed by a 0. Yes, you can only count how many zeros there, and then you will put it beside the 1. So we have 1000. Another was this. 2 cubed or 2 raised to the power of 3 does not equal to 3 squared or 3 raised to the power of 2. Since 2 cubed or 2 raised to the power of 3 is equivalent to 2 times 2 times 2 and equals to 8, while 3 squared or 3 raised to the power of 2 is equivalent to 3 times 3 and equals to 9. So we need to be careful about this. When the exponent is 1, then it's just equal to the base itself, like this. 5 raised to the power of 1 is equivalent to 5. 7 raised to the power of 1 is equivalent to 7. 10 raised to the power of 1 is equivalent to 10, and so on. But be aware when 0 is an exponent, because it makes any number equals to 1, like this. 5 raised to the power of 0 is 1. 7 raised to the power of 0 is also 1. And 10 raised to the power of 0 is 1, and so on. This time, to test your understanding, kindly locate the base and exponent in this exponential notation. I will give you 5 seconds to think. Here we go. Number 1. 8 raised to the power of 6. Correct. 8 is the base and 6 is an exponent. Next, number 2. 6 squared or 6 raised to the power of 2. Correct. 6 is a base and 2 is an exponent. Last we have number 3. 7 cubed or 7 raised to the power of 3. Correct. 7 is a base and 3 is an exponent. Wow, you're all doing great, children. Let's keep it up. Now we have to do was to simplify this following exponential notation. I will give you 10 seconds to think. First we have 2x multiplied to 4x. Correct. 8x squared is our answer. Next we have this. X times x times x times x times x times x times x. If your answer is x raised to the power of 7, then your answer is correct. Last we have this. 3 raised to the power of 5. We definitely have 27. Yay! Very good, children! It seems like you're ready for another show. Well, I'll give it to you. Number 1. 4x is multiplied to 5x. Number 2. 6x is multiplied to 2x. Number 3. 7x is multiplied to 3x. Number 4. 7 squared or 7 raised to the power of 2. Number 5. 8 raised to the power of 6. Number 6. 9 raised to the power of 7. Number 7. X times x times x times x. Number 8. X times x times x times x times x times x times x. If you're done answering, then let's check your answers. Now, let's start with number 1. 4x multiplied to 5x. We have here 4 times 5 is equals to 20 and x times x is equals to x squared. Why x squared? Because it has an invisible 1 exponent there at the top of every x. Alright, 20 multiplied to x squared is 20x squared. Now, let's go forward to number 2. 6x is multiplied to 2x. 6 times 2 is equals to 12 and x times x is equals to x squared. There are invisible 1 as an exponent at the top of every x. So 12 multiplied by x squared is 12x squared. Now, let's go to number 3. We have 7x multiplied to 3x. 7 times 3 is equals to 21. Then, x times x, again, it is x squared. And 21 multiplied to x squared is 21x squared. Going forward to number 4, we have 7 squared or 7 raised to the power of 2. where we say 7 times 7. And 7 times 7 is equals to 49. And number 5, 8 raised to the power of 6, where we say 8 times 8 times 8 times 8 times 8 times 8. First is 8, and it is equivalent to 8 raised to the power of 1. Second is 8 times 8 equals to 64, and 64 is equivalent to 8 squared, or 8 raised to the power of 2. Then 64 times 8 is equals to 512, and it is equivalent to 8 cubed, or 8 raised to the power of 3. 512 times 8 is equals to 4096, and 4096 is equivalent to 8 raised to the power of 4. 4096 times 8 is equals to 32,768, and that is equivalent to 8 raised to the power of 5. And finally, 32,768 times 8 is equals to 262,144, and that is our equivalent to 8 raised to the power of 6. So our final answer is 262,144. If it is in our Philippine peso, then we can make a house in this amount, right? What about number 6? Let's try number 6. 9 raised to the power of 7. So we say 9 times 9 times 9 times 9 times 9 times 9 times 9. And then our first here is 9, and it is equivalent to 9 raised to the power of 1. Second, 9 times 9 is equals to 81, and it is equivalent to 9 squared, or 9 raised to the power of 2. Our third here is 81 times 9. It is equals to 729, and it is equivalent to 9 cubed, or 9 raised to the power of 3. 729 times 9 here is our fourth, and it is equals to 6,561, and it is equivalent to 9 raised to the power of 4. And 6,561 times 9 is equals to 59,049, and it is equivalent to 9 raised to the power of 5. Now on our sixth step here, we have 59,049 times 9 is equals to 531,441, and it is equivalent to 9 raised to the power of 6. Finally, we have 531,441 times 9 is equals to 4,782,969, and it is equivalent to 9 raised to the power of 7. So our final answer here is 4,782,969. Imagine if that money is converted into our Philippine peso, then what should we buy it for? We can buy houses, many and lots of houses, or cars, or any groceries, or just help other people. Alright? Now let's proceed to number 7, our second to the last number. We have here x multiplied to x multiplied to x and multiplied to x. we have here, since there are invisible 1 as an exponent of each x, then we just count the number of x there. So, 1, 2, 3, 4. So our answer is x raised to the power of 4. And last but not the least, number 8. X multiplied by 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 x and multiplied by x. Now we just count the number of x's there, same as we did in number 7, since there are invisible 1 exponent there in every x. So let's count. 1, 2, 3, 4, 5, 6, 7. There are 7 total x's in this exponential notation. So, answer here is x raised to the power of 7. To test how much you learn and understand this topic, I will ask you some of these following questions. I will just give you 10 seconds to answer. So let's start. Number 1. What is base? Number 2. What is exponent? And number 3. What is exponential notation? Alright kids, now I want to give you a word problem about exponential equation. So here it is. Listen to me carefully as I say the problem. 5 kids went to the bakery store to buy some breads. A piece of bread cost 5 pesos. If each one of them bought 5 breads, how much did they pay in all? Now, let's try to answer these following questions. Question number 1. How will you find the amount to pay in all? Well, our answer to this question is multiplying 5 times 5 times 5. 5 is the cost for bread and 5 for the breads they want to buy, and 5 because they are all 5 kids. Alright, number 2. What exponential notation is seen in the problem? We can see 5 cubed or 5 raised to the power of 3 as an exponential notation here, since we consider 5 times 5 times 5. Number 3. What is the ask in the problem? The ask in the problem, or the question in the problem, is how much did they pay in all? Number 4. How many times did you multiply 5? Alright, we multiply 5 3 times. And now, how much did they pay in all? Now, they pay 125 pesos in all, since 5 times 5 is equals to 25 and 25 times 5 is equals to 125. Alright, now it's your turn to answer these word problems. Well, grade 6 pupils, that's it for today's video discussion. I hope you have learned something more about this video. See you in our next learning episode. Remember to study your lessons, have fun, and keep safe. Thank you for watching, and God bless everyone!